Hi, this is Abika from Team 15, and for our final project, we have selected heart rate prediction using electrocardiography. So, I would be giving a demo of the web mobile application we have built for doing this. So, the aim of the project is to predict bradycardia, and so it has three steps. So, first one is data collection, data pre-processing, and data bradycardia detection, and then prediction. So, yeah, so to start with it, let's start monitoring. And so this is the home page of the application, and over here you could see these radio buttons. Okay, so as for the first step, data collection, so we the 5 team members have contributed for data collection, each 10 hours each person for 5 days. And this data is collected using the wearable sensors which were collected from the impact lab. And the data has been so after this collection, we have to pre-process the data. So for that, we have cleaned the data and denoised using low pass and high pass filters, and which was implemented in MATLAB, and which was advised by the impact lab also, TA. And after this we have to find the heart rates. So in order to find the heart rates, we need to find the R peaks. So R peaks are the to find the R peaks, we have implemented the R peaks detection algorithm. And from which we will show, I mean, we can find the heart rates of each person from the data. So the data would be different, and we have to find the heart rate from that data. So here, as you could see, there are like 5 different files for each person. So let's say for this person we have selected the file. So these are the plots of the heart rate per and against the time and ECG. And so here you could see two things like detect and predict. So for detection, I'm just going to so for detection, what process we are used is like for detection we have used two things. So one thing is like detection using sliding window of 4 minutes to obtain feature information. So average heart rate in this interval of 4 minutes is compared with the threshold, which is 60. So any heart rate which is lesser than 60 is considered as bradycardia. So the threshold kept is 60 bpm. So now in the sliding window of 4 minutes, we have calculated average heart rate of each sliding window, and then we have compared it with the threshold. So this is bradycardia with window. And without window is manually annotating, basically. So manually annotating is nothing but like just comparing every heart rate with the same threshold, which is 60. So we are doing both of these in order to compare the false positives and false negative. So let me show a demo of the detection. So if you click the detect button, so you could see the time taken for the detection. So time taken is the execution time, and also detection results you can see as like without window, which is basically comparing every heart rate, and with window is like comparing average heart rate for 4 minute windows, and 4 minute intervals, sorry. And then the false positive and false negative rate is comparing both these things. For the bradycardia prediction part of the project, we have referred our research paper called the Preterm Infants Using Point Process Analysis of Heart Rate. In this paper, they have used point process analysis of heart rate for predicting bradycardia in infants. We have also used the same approach where we will calculate the mean and variance values from the given heart rate, and then normalize these values by using multiple iterations of data and calculate the cumulative density curve. This cumulative density curve will be used for k-mean clustering algorithm. The reason why we have chosen k-mean clustering algorithm is that we assumed we could divide our data into two clusters, like the data the data before bradycardia and the data after bradycardia, because the heart rate before bradycardia was much distinct and easy to identify. So we've chosen k-means clustering algorithm to move ahead with. So the we've calculated the cumulative density curve by estimating the sum of all the normalized mean and variance values as a function of distance from k-means clustering centroid. And the density collection of normalized mean and variance will be given by the steep inclinations of the heart rate curves which we've obtained. Thus we have went ahead with following the k-means algorithm, which will predict the bradycardia presence based on the data given into it. Let's see how the prediction, for example, data given. Here it says 40 bradycardia predicted based on the data we've given, based on the sample data we've got, and the algorithm has given the prediction that 40 bradycardia are predicted. For this data, it's 47 bradycardia predicted.
Of the code we have developed for our project. So this is the MATLAB code which we have used MATLAB for the purpose of denoising and the cleaning of data, and later we have also used MATLAB to find the peaks in the R peak values in the data, which we have used further to calculate the heart rates of the data. So this is the code. We are reading the ECG signal data, and we are performing we are passing it through the data through the low pass filter, and later we are we are removing noise, and uh, later that signal is used and is sent to this RPEG detection file, where we are finding the PR peak values. So this is where we are finding the R peak values, and using those values we are plotting we are also where we are finding the heart rates. So later, after finding the heart rates, we are also, so this is where we are finding the heart rates, and after finding those heart rates, we are using that data to annotate manually the bradycardia. So we have a threshold value of 60 bits per second. So we are just checking if the value is lower than 60 bits then per second, then we are annotating it as bradycardia. So this is the code where we have done the same. So now let me go through the Android app which we have developed. So this is the Android app. It has four activities. So first one is the main activity from which our Android app launches. So this is the main activity. It calls the prediction. It calls the display activity, from which we have displayed some video buttons for each individual, and we have a button called select file, which shows the heart rate and ECG plots of a of a person. So these are our group members, and we are just viewing the images which we have got from the MATLAB code, which I have just shown. So then we have another button which is called detect, which launches the detection activity. Now let me just give an overview of the detection source code. So we have used a sliding window of 4 minutes, and we are calculating the average values, and we are comparing those average values with our threshold, which is 60, and we are marking all those points at which the value is below 60 as bradycardia. And later we are comparing the data generated using this algorithm with the manually annotated bradycardia data. So we are also calculating the false positive and false negative parameters. So if the value, if our algorithm shows a point as a bradycardia, and the manually annotated point shows that it says that it's not a bradycardia, then we are calling the situation as false positive. And if we at a point, if we say at a point, if it's we say at a point it's not a bradycardia, and we find that in the manually annotated data we find that point as bradycardia, then we consider that scenario as false negative, and accordingly this is the code where we are calculating all those values. So now let me go to the source code of the prediction. So this is the source code of prediction. We have used point process analysis as a method, and we are considering the variances of the heart rate to calculate the pre-bradycardia condition, and we are using that uh, to predict the uh, bradycardia in the future. So this is the code for the prediction.